Now here we have to find the derivative of x square using first principles. So as we have seen just now that first principles means we have to find out the derivative as the specific limit as mentioned in its definition. So to begin with, let us call the function whose derivative we have to find as say f of x. So our function f of x is nothing but x square. Right? Now we know that the definition of derivative says that f dash of x is equal to limit of f of x plus h minus f of x whole upon h as h tends to 0, right? So therefore that gives us limit as h tends to 0. Now to write f of x plus h, if we see the definition of the function, that is say f of something is equal to something squared, isn't it? That's the function. So therefore f of x plus h will be nothing but simply x plus h the whole square minus f of x is x square as we know whole divided by h. So that further gives us limit h tends to 0. Now x plus h the whole square will be x square plus 2xh plus h square minus x square whole upon h. So we see that x square will get cancelled. So therefore evaluating further we have limit as h tends to 0. Now from the remaining quantity in the numerator we can see that we can take h common. So what remains in the bracket is 2x plus h whole divided by h. Now we know that since h tends to 0, h has not become 0 yet. So since h is not 0, therefore we are allowed to cancel h here, and therefore we are left out with finding the limit of 2x plus h, and which is a simple polynomial. So that is nothing but 2x as it is, because x can be thought of as a constant from the perspective of h, because it's the h which is the variable of limit, and 2x plus 0 which gives us the final answer as 2x. So the derivative of x square turns out to be 2x. Let's see one more example which involves a trigonometric function, that is we have to find the derivative of sine x using the definition of derivative. So once again here we have the function as sine x. Okay. Let us write the definition of derivative once again, that is f dash of x is given as limit of f of x plus h minus f of x whole upon h as h tends to 0. So that is limit h tends to 0. Since f of x is sine x, so f of x plus h will be sine of x plus h minus f of x is sine x whole upon h as it is. So that further gives us limit as h tends to 0. Now if you see, sine of x plus h minus sine x whole upon h will give us 0 by 0 form, right? So either we can use L'Hopital's rule to evaluate that, or even without using that we can use a different method to evaluate this limit. For this we observe that the numerator is of the form sin a minus sin b. So we can use the factorization formula and write that as 2 cos of first angle plus second angle whole upon 2, that is x plus h plus x whole upon 2 into sine of first angle minus second angle, that is x plus h minus x whole upon 2 and whole divided by h. Okay. So that gives us further limit h tends to 0. Now let us write the cos term first. So here we get cos of x plus x gives us 2x. So 2x upon 2 is just x, and the remaining h divided by 2 gives us this particular expression, that is cos of x plus h by 2. Now what happens in the sign? In the sign we see that in the numerator x will get cancelled, so we are left out with just h upon 2. Now we sense that we have a sine term, alright, and we know the standard limit, that limit of sine x whole upon x as x tends to 0, alright. Limit of this particular quantity as x tends to 0 is nothing but equal to 1. So therefore we try to adjust that particular denominator. Now if you observe, there is 2 here and there is h here. So we write it as, in the denominator we have to write h upon 2, so that the angle which is present in the sign is exactly adjusted in the denominator. Okay. So now therefore, taking the limit further, if we now substitute h as 0, we will get cos of x plus h by 2 turns out to be 0. So therefore the first term is nothing but cos x, and in the second term we see that the standard limit sine of h by 2 upon h by 2 as h tends to 0, which is nothing but even h by 2 tends to 0. So therefore that second limit is equal to 1. Okay. So therefore we have cos of x multiplied with 1. So therefore the final answer is that cos x. So therefore derivative of sin x is cos x, and we have to remember this as a standard result, because many times we need to use the derivatives of such standard functions.